Good evening, everyone. Tonight is Thursday, 4/9/2020, and we're going to cover a lot of regular expression. Tonight we're going to use a lot of the examples with set, which is a stream editor. And I prepared a lot of scripts there for you so we can practice those. And set is stand for stream editorial, as you can see on the screen. Basically, it does allow you to, like VI, when you're opening a file, you're opening the data file, you're modifying it, whether you're using Vim or VI. But with a stream editorial, it's the opposite of what VI does. Every data that you're working, it's a stream of lines that set is going to open it either as a pipe to the set command or reading it from the standard N, which is a file. And then once it reads the entire file as one time. So it passes it through once, but it does parsing as it goes line by line. And it's really fast. It's not slow at all, because it does read it once and then manipulate the parsing all in one pass. So the stream editorial, like awk and gawk and grep, cut, all those other commands I have been giving you examples of. We went through awk and the other day and gawk, and we used a lot of examples for it. The stream editorial is similar to that one. It does support the regular expression, and we're going to go through some examples of regular expression as well on this session with using set, maybe cut, maybe other commands as well. And we're doing a lot of for statement, if statement, comparison, and those situations within the script itself. But at this time, let me just explain the commands that are you're seeing on the screen. So when you do a what is set in Unix, whenever you type in what is command, the what is followed by a command, it gives you the description, a short description of what that command is. And some of you guys chose the assignment for the midterm to write in the what is section. I was explaining to one of the students last session. Basically, the objective of that assignment is to be able to write a script to just parse through the man pages, list of, first of all, on every distribution version of Unix, Linux, Mac, whichever version that you're using, there's a user share man page for it. Under the user share man page, there's a list of, there's a user share man directory which has the man pages. When you do the man command, it just lists all the files. So what you want to do is, for this script, you want to go through that directory and find out in the list of commands, then use grep, cut, awk, whatever you're set, whatever you're interested, to just parse out only the command part of it. And then once you do that one, then you go to a while read var and then just manipulate it and then do whatever command you do. For example, what is that command? You could do that as simple as that. And if you want to write it in HTML, so it is open to a browser, you could do that as well. Once you are doing the what is, on each what is, you're going to write in a nice HTML file by opening an HTML file earlier enough, and then creating a table. And every time, for every row that you go with the while read var, you just add a table row, table data, close the table data, table row, and then at the end close the entire table and close the entire body of HTML and close the HTML page. And that would just make it a very nice HTML file for what is section. I showed you a section of it last time when I was explaining how I did one of the a script to just print out the environment, env command with all the query string. So you could use that as an input to see how I'm going to parse out and match out regular expression. But not in this case, you don't need the regular expression comparison, but there was another assignment to write a calculator. The basic calculator, I explained to that student also, if you're interested to write basic calculator, normally similar to the BC, I'm not expecting you to write the full BC functionality. I'm expecting to do it what the content of midterm would allow you to do. So maximum of maybe 10 functions and minimum of 5 functions. The functions could be addition, subtraction, multiplication, division, modules, maybe square root, maybe power of functions. If you're interested to add up any other scientific for bonus point, you could do that too. That script basically is asking you to write like a calculator that would be working similar to a basic calculator. Maybe yours is a little bit better because you already know what a basic calculator does, what is the strength of the basic calculator, and maybe something you might want to improve somewhere there. You could just add on those features if you feel like. But the class, when you're doing that one, as long as I see, for example, let's say you're doing division and then you're comparing the numerical values on the division to make sure that the denominator is not 0. So division by 0 is not allowed. And then that kind of condition is checked. And then maybe some validation that when somebody insert, they don't write as input text. And then you just try to add up the two, this and that. You just have to make sure that they enter integer or floating point value if that's what your script is expecting it. So that would be your decision. The other question that was brought up to me, I think, was, and can I use basic calculator as a kind of command inside to just do floating point calculation? Yes, you can. For example, if you're seeing that if when you do add up two numbers and $1, $2 as integers, and that is fine, but as soon as you put it as floating point numbers, that will not work. So the way you do it is you do echo the two numbers, pipe it to C, and then that would return the result in a floating point numbers with the summation if you have to do summation. I hope I answer all the question. And if you still have question, don't worry about it. Just do the homework. That's part of the learning. The learning curve is to just see what your imagination is gonna bring you into this class and your future classes. You have to think outside of the box in order to say, well, what is the best method to write a calculator? Not that what the expectation of a teacher does or the expectation of your boss does or something. You find out a way that you could just make this feature that is not there and you could just add on to it. So it looks like a very good program that was built by you, not somebody else's idea. You just took it and then you implemented it, and it was easy to do that. It's a learning curve. It's going to help you. I hope everybody's good with that, with all the assignment, and you have enough time until next week to submit all of that. And then for the final, I'm going to still come up with a project for the final, and the project for the final might be on top of what you're building. So let's say you choose addition, the function for doing the what is section, then I might just ask you to do similar to that to make sure that it works on the web, for example. And let's say there's some additional features that you would upgrade your script to a higher level. Like for example, on a calculator, if you wrote 10 function, what about if you do the scientific, what can you make it in a graphical interface? So it would work with GUI. Of course, I'm going to cover in the next session or a few more weeks that we have left, at least we have a couple of months left for now till June. I'm going to cover graphic and I'm going to cover X session and everything else. And you will be good with all of that. So at this time, let's go back to the lecture. Set is, if you do the type minus A, type by itself without dash A for all is going to just show you the set in binary. And if the set command is also like a PWD that's a built-in, it will show both version of it. So in this case, the two versions are both binaries. One is residing on the bin directory, one is on user bin. Which set, it tells you basically the path to the which, similar to like locate does. Locate has a little bit more kind of information and in comparison to which. Locate DB is something that you run on Unix to just, and when you install locate, after you run the locate command, it says, oh, the locate DB file is not found. It's a database file. Once you upgrade that one, apply the locate DB command, and then your command is all kind of like searched. At that time, the locate DB will have an up-to-date of all the binaries and all the files that are residing on your system. So instead of saying which set, you could say locate set. Anything related to set will be listed there. The whereas command is just shows you the location of any file related to the where the set in this case. And then yum provide set. That's a CentOS or Red Hat repository command. Yum stand for Yellow Dock Update Manager. When you want to look for a particular binary to say which package this binary was installed, that's your friend, that's your command, yum provide set. You type in yum provide set and it refers the binaries or the RPMs, in this case, the packages that are installed. In this case, there are two packages. One of them is set with EL7 x86, and the other one sometimes is one is in this case is both of them are showing. Let me see what is the difference between the two. Normally, if there's one for Intel version, one for x86, one for ELF format, and all of those ones will be listed. But the repository in this case, one is from the base, the other one is from Anaconda, and that's what the difference is. But both of them are GNU streams. And then when you do the minus QA query all, you will get the pound sign back. I didn't do that command, but if you do that one, you will get the pound sign back. If you do the -QA command followed by the package name, if the package is installed, you get the prompt back. If you do echo $? You see 0. And if you don't have the binary installed, it says this package is not installed. So now you do query -L for listing it, and then you would just get a list of all the binaries. Normally, every binary, every package that gets installed on your system, there's a /bin directory for the actual main binary, and then there's a user share for all the documentation. User share doc and info. So the info command that you run on Unix are all here. And then user share man pages or user share doc pages are all the documentation that are basically based on commands that you could search when you do man set. For example, right here, user share man1. Under man1 section, there's a set.1.ganzip. If there was another version, man2 or man3, then it would be set.2.ganzip or set.3. So on your what is script, you look at this man pages directory, user share man. On the what is script that I was asking you to do, you look for this one, and then there's man1 through man9, let's say, or whatever other commands that are there for printing or anything that are outside of the man pages that are for device drivers, there's a name on it. You could just look for all of them. All you have to do is go to this is basically the base name, go to the base name and then take from the dot, the first field, cut minus D dot, and then minus F1. That would give you the field 1 from that line on, and then that would give you all the commands. And then now you have the list of commands, send it to a file, then parse it to your what is script. The RPM, this one, I'm just looking at the bin directory for it, and I see that one is there. So file bin set, this file command tells you what type of file this is, a text file, binary file, an image, anything. Normally, when it is executable on the system that it gets installed, it will have this ELF format. ELF stands for Executable Link Format. The reason it says 64-bit because the operating system is a 64-bit version of Linux. If it was 32, it would say 32-bit. But if it was 32 in addition to 64, then it tells you that this binary can run backward compatible to 32-bit OSs as well. And then in this case, it's already a 64-bit. It just installed a 64-bit of it. When you do the yum install, automatically, it just installs based on the /lib64 directory. And then you see this /lib64, those are the 64-bit. So there's a LDD command that I'm showing you here. LDD is listing the directories of the device drivers or the shared object. All the shared object, the linker or loader for this binary that says, okay, I need to find out this shared object file in order for me to link the executable at the time that it runs. So this executable /bin set needs these library files. Like similar to Unix, similar to Windows, you have .dll dynamic link libraries. On Unix, you have .so. .so files like this, it stands for shared object. These are dynamic link libraries of Unix that as soon as the binary is called, it has to load this Linux vdso.so.1 in order to access all the functions that are available inside of this library. And then it loads it in memory dynamically, and then it does it. That's what the LD stands for. Loader dynamically, it just finds the module or the library in this case and loads it. There's another type of file in Unix that's also a library file. It's called .sa. That one is a static object. These static files or static libraries. This is a shared object. The difference between shared object and static libraries, let's say you have a library called print library 1.sa. As soon as you name it the extension .sa as a shared object, you're telling the binaries that I'm going to load my functions on the memory at the time of I'm being called. I'm not going to load it dynamically. And once I'm loaded on that one, if program 1 wants to print a file, is going to print that file. And if program 2 or user 2 wants to print that file, I have to load it again into memory. Every user that wants to call that function, there's an area of memory will be allocated to read and load that portion of the function that is accessible by the program to load it in memory. So the function is being called as many times as the user needed. That's very inefficient way of just using the memory. So that's not efficient. In order to make it better, you use .so files. The shared object files, it doesn't matter if 1,000 people are accessing a function. Once the content of that memory function is loaded into memory, all it is a pointer to that area of memory, and then the program 1 through program 1,000 or user 1 through user 1,000 can access it without any problem. So I showed a little bit highlight of man set command here. As you can see, the set command basically is stream editorial for filtering and transferring text. And it has some description explained here. The option that is there, -n, which I'm going to go show you tonight with -n is suppresses the command. Basically suppresses the output. If you don't use it without the P, the output will not be shown. But if you pass it with the P option, in addition to putting it, searching for the line that you're finding it will print that line only, not the files that are not matching or the lines that are not matching. So the lines that when you do -n with the P, it only prints the line that is matching. The other lines that are not matched, it will not be printed out. If you just do it without -p, none of the line will be printed out. It suppresses everything. So -e option is to use an expression. In this case, it says a script or -- expression is equal express. Basically, it's a regular expression. Whenever you see the command -e, whether you use a grep command or awk or set, any of those commands, it is looking for a regular expression. And that regular expression, you could put syntax similar to what we discussed for grep, what we discussed for awk, and what we are going to discuss for set today. And then there's another option that I'm not showing here, -f. -f is going to look for a file, a set file, and then run it against it. Actually, when you do a set --help, -f is also showing here, so I'm showing it here. But I noticed that after -e, I cut that rest of the man pages because otherwise that would be too long. And I told you that on the boldface here, please read the rest of the man pages for set during the lab and practice it as time allows for it. You should practice all these options that are there. You can see there's a lot of options. This is the set -help. I'm going to show you a number of these syntax and examples and outputs with other scripts. Okay, and so the next topic that I'm going to cover here is the actual script that I did. Today lecture, I'll cover at least the following scripts. So when I'm saying the following script, these are the scripts. In addition to set command, cut command, awk command, gawk, grep command, egrep, while, for statement, while statement, if statement, variable declaration, looping, and writing different type of scripting, and so on. All those things will cover tonight. And sometimes you could see certain commands. I have been covering it almost in every lecture. That's because, like, if you want to write a for statement, and every time you teach, you might hit a for statement or a while statement or a if then also statement or some kind of comparison. There's going to be some case statement and select cases also that I covered in the past. Case statement, I have not covered select statement. There's going to be some more examples next time using case and select and writing maybe dialog boxes and so on, all those things on the GUI interface as well as command lines. So those ones will come also. At this time, I'm going to go through the Linux session and show you each one of these scripts, the detail of it. And then when I'm done with this lab, I'll post these scripts. Even though I posted here, I'll post it with running output and everything as a result of each command, okay? Let me just browse a little bit slowly on this. So this is each of the script is listed here. It might be like half a page to a page long. There's 5 or 6 of them, 5 of them. And then at the end, there's an end file that is also created by the script. The end file gets created in this set file. Set file I created manually just at that time. You could also script that one, not a problem. So let me just go back to my Linux machine and I'll cover set show. Let me make sure that nobody is waiting on the list. Okay, I see people are here. Okay, that's good. Minimize and then go back here. Okay, on my this directory, let me do a man set just to show you the full man pages. It's gonna be like, I'm not gonna stop too much, but I'm gonna just show you that option that we went through, and the rest of them I did. See, the -F option is right there. So -F dash script command, and then dash follow symbolic link if you want to do -C for copying it, -B for binary, POSIX, regular expression, extended regular expression, separate. All of that options are there. Address also I'm going to discuss when you're referencing some address space. You're just giving the number and then you want to do, once you search for it, what you want to do with that one. Delete it or insert or append to the new file, what you want to do that. So as you can see that when you're learning, always look at the see also section. This one is related to these other commands that you should know. One of them, awk, we already covered. Ed is the editor, before we had the vim or vi or sed and other ones. Ed was original editor of Unix. Grep command, you know that grep command, egrep, fgrep, we covered. Grep stands for global regular expression print, and then egrep for extended grep, and then fgrep for fast or fixed string. It does not match. It does not match regular expression. Fgrep, which stands for fixed string. It does really fast of a string that is just fixed, because it doesn't do regular expression comparison. Therefore, it's faster. The grep command with the minus uppercase E, when you pass it on, you could use it as egrep. And when you do with minus uppercase F, you use it with fgrep. And if you just do it the standard way without any argument, it does support a regular expression, but it's not like egrep. Egrep was, in addition to do the standard regular expression, it also supports for matching a number of arguments. Like maybe you could pass on multiple argument for the egrep options. While you're searching it, pipe it with the OR statement. There's this AND statement, OR statement comparison you could do as well. There's that braces and then the minimum maximum number of occurrence of some pattern. You could do that with as well. Translate command is really nice if you want to just translate a certain character, let's say for example, from uppercase to lowercase or lowercase to uppercase, alphanumeric to something. There's a lot of different version of syntax that it supports it. We will go through that as well. For a regular expression, that's similar to UNIX, CentOS or Linux GNU version of regular expression versus BSD version. So it's really nice to know a lot of these ones. You can go through the man pages for each one of them when you go there. For example, when I do what is set, it tells me that. And remember, I was telling you that when you do type minus A set, it tells you that these are the two binaries. If I say type minus A PWD, you can see that one of them, it says PWD is a shell built in. So if I'm using bash, PWD is there. But if I just type in PWD here, I say which PWD, it tells me the user bin PWD is there. So whether I use user bin PWD or PWD, it will just give me the same thing. But when you do type minus A set, you can see that that file set, and if I say file, let's say I do that, and remember I was telling you that, yeah, I'll cover a little bit more. So let's do just while read var, and then do, now I'm going to pick up only field number 3 of it, right? So, and there I could just say field 3 is equal. If I just forgot to put it after this while statement, I could still have a chance to do it here. I could just say, I'm going to put the backtick here, backtick, and then I say echo $var, but then after I put $var, now I'm going to do, this is one field, 2, third field. Then I could say awk print $3, $3, and then close that one, close this one, and then close the backtick. Now field 3 has the user bin set and user bin set. So now if I say echo $field 3 done, it will just say those two files. But if I assume that I have that one in my command line, all I have to do is now I say, do a file on it. What type of file they are? Their user bin. If do a long listing of it, then it's the file, do a list minus LD on it. So as I go through it, and then now I'm inside the loop, I could put another command while it's doing the list. I could say LDD on that $sign file. See, it does. So this LDD.set was not recognized, but this one is there. So where is this one dot is coming? Because when I did the ls, it just this file become a problem. So I'm going to try. Actually, that was not the problem. The problem was I should have done on $F3, not var. Var had everything, the ls command and other ones. So now I'm going to do this, and it shows exactly what I'm looking for. The first one, and then I could just put another statement here, say echo working on $F3. Notice I'm not putting braces because at this time I know that I'm not having any extra character or anything. So I could say working on this and then comes out there. But I could just put, for clarity, if there is any confusion, I could just do this as well. And then the same thing with right here. You want to just be always safe than sorry. Later say, oh man, there was an extra character and it did not understood that variable because there was either a space or something that was causing it to not work. But this one, the ambiguity is gone because $F3 says the content of that variable. So in this case, we just looked at some of the functionality of those, and then all of these ones are standard libraries that are there, and these ones that are not showing is also pointing to the same one, as you can see here. So if you look, for example, for one of them, let's look at the one with this shared object. We're on the system level now. So if I say file that command, and it says that it is a dynamic link built ID, this one. And the only information that I can do on this one is to do LDD on it. And that one tells me what other libraries are linked with this one at the time. I could also do a strings, and because this is data file binary, I could just see some of the content of it, but it's not going to be nice. So I'm going to just do head -5. And this 5, you can see there's not like clear text information or anything because they're object file, shared object files. And then when you do a file on these ones, if you do file on it, it tells you that that's the executable link shared object. It's an object file, and that's how that one is going to be referenced by certain. There's a lot of system tables, symbol tables, a lot of information functions inside there that is being called by this binary like set, but it's all internal. So the objects that when you write a C program, or in this case C or C++ or Java is bytecode, but C and C++. When you write it, these programs are written in C, so the executables are all having the abstraction. You will not know what's inside there till you actually go to the source code. Okay, so I was right in this directory and I was doing this. So now I'm going to show you the first example, set1.sh. If I do vi set1.sh, some of the commands that you're using in set is also working on vi. Okay, for example, let's say on set, let me show you one file quickly. Let's say this file called nfile.txt. This is the file that I'm creating by my script. So if I copy the nfile.txt as a new .text, okay, new file. And then and now new file.txt is just a copy of the same file, so it's there. If I want to do a command on this to substitute certain thing in it, I'm going to show you one quick way to do substitution on the new.txt, and then I'll show the same command on VI. So you could see what you learn, whether you do it inside VI, you might be able to do the same thing in the set, or vice versa. So let's say in this case, new.set has this, new.text has that contents. I want to just change every aspect of the word, let's say, is there cat? Okay, there's cat there, right? So if I just say set, and then I say substitute cat to dog in the file called new.text, it basically changed the cat to dog. But it wrote the output onto standard output. So if I look at the file again, it is still cat. I did not modify that file. I just wrote it into standard output. I could always write it to another file or something to modify it. So let's say I wanted to do that same thing I did here. This time I'm going to write that output to a new file, new1.txt. So this one, it just prints out what I'm looking for. And then the new file, sorry, that's my new1.txt, also got created, and then cat new1.txt, changed it to dog. So now if I just do a diff between new.txt and new1.txt, you can see that those two lines are the only difference. It modified those two files. So the commands that you're learning inside the set command here on the command line, you could put in a script, it will do the same thing. But inside the vim or VI, I could do the same kind of substitution. Notice I'm just opening the file. Let's say I'm gonna do VI. What was the file name? New.txt. Okay, inside new.txt, cat is still there, right? So if I want to change the cat, here I could just say 1, comma, $, meaning from line 1 through the end, substitute the word cat to dog. Okay, this will change it. If I just type in G, meaning globally, it will change every occurrence of it. But since I'm not doing it, it only has one aspect of it, it just only changed that one. And then notice that it changed that one. If I just say 1, comma 3, because I know there are 3 lines there, and then I say substitute dog to back to cat, and then put a G globally, it will still do it. Now I'm going to say 1, comma 3, and write it to a new file called new1.txt. So that W for write, it will just do the write, 1, comma 3, write new1.txt. Add this one to overwrite it. So that file already exists, so I have to do the bang. Whenever you're on VI, if you want to overwrite a file, if I say 1, comma 3, write new2.txt, it's not going to prompt error out. It's going to create it. But now if I redo that one and say 1, comma 3, or end of line, $, or 3 in this case is the same, write new1.txt. This one will say this file doesn't exist, you have to put the bang. Watch, it already help you. So what I do is I do that command the way they suggested, 1, comma 3, write to new file, new1.txt, and I'm going to put the bang here. See if it understands. Yes. because it understood that syntax. So I go here, I just modify something, and I want to quit. If I just say quit, it's going to say, oh, and there was a write. You don't want to quit without making sure. So if I just say quit for sure, it is going to do that. Now the new files that I just created, it has those there. Whatever change was written at the time that I wanted to write to it, it was there. So if I just say new 2.text and just go substitute one, you could do substitute one through that one, or you could just say percentage. 1, $, and percentage means the same thing. So that means through the end of the line. Change the cat to dog, and then that did it. Now I'm just going to write it, and I'm done. Now new 2.text has the word dog. So let me remove these files. You understand that when you're inside of the VEM or VI, you're able to do the same kind of set comparison there. So this new file, I don't need it. Or new file.text and new file. Okay, so if I just open up the file vi set1.sh. In this example, let me go to line number 1. In this example, I'm saying that the script will generate an input file called infile.txt, which is if for short, and then with some data using an array, and then the array will just write some information to it. And then later on, we will demo some stream editorial examples. So in order for me to just fit all my echo commands in one line, so it doesn't go through the next line and it is too long, I created these variables. And these variables, this is another skills, or this is nothing, but this is another method actually that would shorten your script to writing shorter lines on each line. So you don't go for like 5 line or something. You just create a small variable for it, like the ferocious, I just put fs, and the fierce, I put fe, and the br is the brown, the quick brown, and then cs is the cute small. So in this case, what we want to do is create an array. The array has lion, hyenas, wolf, fox, and cat. Those 5 animals are listed here. And then as we go through the, in this case, I'm not actually doing a loop because I don't need to. I just declare an array, and I'm writing the array sub-0, which is line. In this case, it should say the ferocious lion runs after the hyenas, and it should write that information. The second one, fe, is the fierce. The fierce wolf, that's index 2. The fierce wolf ran after, chased the fox. And then the last one, the quick brown fox, jumps over the cat. So the small cat, the small cute cat. So it will just write that information. Once it writes it, then I'm going to do some set commands on it. For example, in the first example, I have put a lot of comments here. The reason I put those comments, so if you just are not listening to the lecture and you're reading the input file, the script file, you should still be able to know what I'm doing. And that way you can just take the comment out and practice it, see what we're practicing. But for clarity, I took some of those comments out, so there's not too much information on the standard output when we look at it. And then I put some echoes or pauses in order for the screen to pause, and then that way we can see a better output. So for each of these commands, I'm also showing the actual command that I'm running. Like in this case, I'm looking for set command minus n for suppresses the output for the string line in lowercase, and then print it if it finds it in this file, which is the infile.txt. And as it finds it, this is the actual command that will be run. That command was with echo. And then the status of it, whether it is 0 or 1, it will show. For some reason, the echo, the set command, as long as it finds the command did not have syntax error or something, the status will always be 0. It's not like grep command that if it doesn't find a match, it will just be non-zero, and if it finds a match, it's 0. So I'm printing out the status to show you what the status is there, as well as the actual command. And then the same thing with this one. On this example, I'm using the regular expression. The regular expression is uppercase L or lowercase l. This means or. The bar is or. And you're putting within the search, between a slash and then this slash, whatever you put, either a string or a regular expression, that would be matched against that file. And if it finds it, P for printing it. P is the command to say print it. The command could be P or could be any other commands, G for global, or and the commands here, before that one, the addresses you could also pass on, put I for insert, A for append, and I'll show you those ones as well. This is the first example. Second example, this regular expression, now this time it matches. The first time it didn't match. And this one is set command, that when the regular expression doesn't match, I want to see the status of it. And when it matches, what was the status. Same thing, I'm comparing it here with grep command. When it finds it, what was there, and when it doesn't find it. Like when it says this does not exist, this actually doesn't exist in the field, so it doesn't find it. Grep minus I. I'm going to take this one out, slash out here. That was an extra typo. Okay. So now clear the screen and set one.sh. So what I'm doing here, remember the array? Based on array, I made 3 lines. The furious line run after the hyenas. The second line says the ferocious line run after the hyenas. The second line says the fierce wolf chased the fox. The third line says the quick brown fox jumps over the cute small cat. So in this case, this is my input file. And then the first example, I'm doing a set command on the input file here that I just printed out. That's the output. And the content of this infile.txt is shown those 3 lines above it. And then in this case, I'm doing a minus n to suppress the result if it doesn't match, and then P, if it match, print it. So at this case, I'm looking for line, because line is uppercase, this will not match the case sensitivity. So the status is equal 0, but it returned no result here. The second one that I'm using this example, this time I'm using a regular expression. Whether it's uppercase L or lowercase l, this regular expression is searching for line with lowercase line or uppercase line with uppercase L in front of it. Inside the same file, and it does the same thing. But this time it found it right here. So that first line where it says the ferocious lion run after the hyenas, it matched that one. It did not print the second line and third line because there was no match. So minus n saying that if it doesn't match, don't print it. And minus dash p slash p is saying that if it finds it, print it. But whenever you use minus n, you have to use the p options. because they work together. If you use without the P, then it's not going to show even one line. It suppresses everything. So that was the first example. The second example here, I'm using set with this does not exist. And then notice that since it didn't match, the status is still 0. Now, example with grep command, with this match, if it will find it right here, the status successful. It with a grep command, meaning it found it. When it is this does not exist, in file status is still 0. That's good. So it is similar because we did not have any error. If it was an error, then it would be -1. For example, I say grep some commands that it doesn't exist and run it against some file that doesn't exist, then status would be 1. So the input file was read as input only and did not get updated. Yeah, this part is explaining that since I did the printout all in the standard output on the screen, there was no update on the file. So set by default, it writes the difference, the change to the standard output, not to the file. So it does not touch the file unless you tell them to do so, which is a different command. You could do a W command. So let me see the next command. Okay, this one is set-n-2-n. Okay, let me see the difference between. Actually, let me just do more set2.sh first. Set2.sh, this file is doing the same kind of file. It creates the same input file, but the example here we're changing. We're changing some, in this example, we replace the word regular expression the to that on first occurrences. So when it is on the, when you put this 1, it says on the first occurrence of this file, in file, whenever you see the word the, which is this pattern, whether it's lower t or uppercase T, followed by HE, change it to that. And then only change it the first occurrence, meaning that when the file is, the first line is da, it will change only da to that. The second occurrence, it will not touch it. So that's what this means, the number 1, meaning the first occurrence. This one, it says that change it on the second occurrence. If you see the same word, change it to the second occurrence. And let's see on this one, I'm gonna do set2.sh. So right here, you can see I'm doing substitute cut to doc in file. In the previous line, it just changed it to doc. Substitute that one to doc. And then press enter. Now cat, this one is going to change more than that. So the earlier example I was showing you in the more command, it was a different script, but this script is doing similar change, yet this one is doing substitution for cat to dog, which right here you can see the line dog was substituted. But because I'm not doing any -n option or minus -n option in P, it is just listing these other commands as well. Okay, later on I'll show you the option for the same one. When it does -n, I only show this line. Okay, so set -s cat to dog. This is a to command when you're just changing multiple than one variable. So for example, I'm doing a cat to dog and a quick to fast. Substitute those two strings, both of the string. In this case, the first command is substitute, and then after that one you put a semicolon, and then you change it to a second substitute command. And then in that case, it changed it. So now you can see cat was changed to dog, and then the quick was changed to fast, the fast brown fox. And then here was the quick. So that modified it. And then example number 3, this one is the set command that I was talking about earlier. This one set that, the word da is going to change it, but it has to match out the first line. See the first line, it has the da, all of those da or change to that right here. Because this encore symbol says if it the string is in the first line. The $sign is if the string is at the end of the line. And the rest of them you could do regular expression for it. So this one is changed to that. And then we cover this one. Now let's go to this example. This example, it says when you see substitution to the word, whether it's lowercase da or uppercase da with T uppercase, and change it to that. This time it's not saying the first occurrence, the first line. So it finds it in the first line, but notice there's also da somewhere here. Why it was not modified? Because I didn't tell you it globally. If I say here /G means be greedy, globally modify everything. So that is what at this line, I only wanted to do one word. If I just say line 1 here, would say that change only the first time it finds it. If I just don't do it, it will only change the first occurrence. But if I do 2, it will not update this one, it will find the next occurrence. So watch this example here. Right here, I'm doing a 1. So this is similar to the above. Since I'm changing the da to that, but only the first occurrence, it only updated this one, nothing on these das. None of these das were modified. And then this time, I'm gonna give an option of number 2, and instead of 1, saying that not the first occurrence, but the second occurrence, and that's what it does. So in this case, da is not modified, but the lowercase da are modified on second occurrence on all 3 lines because of that number 2. And then in this time, I'm saying globally, disregard to what was the word because it matched in the first line as well as in the middle of the line. Then it is modified da to that and that to that here. All these 3 lines are modified because I said globally. So everywhere it finds the word da, it modified it to that. So this list / after the search, what do you want to do with it? Do you want to write it to a file? Do you want to globally modify it the first line, modify it the first occurrence, modify it on the second occurrence or the third occurrence? You just put that number there. And then after I did the globally, I just print out the file again and says, look, the file was not attached because set works on the standard output. So we're good with that. Now let's look at the next example, which is set 2-n.sh. In this case, I'm just doing the same command that I did earlier with set 2, except I'm putting -n option. As you can see here, -n, and then -n, you have to put -p as well. So like this example has 2 set search separated by semicolon, but I have to print both of them in order to make sure that both of cat changes to dog and quick to fast. When I'm doing a -n here once, but I have 2 search, I have to do 2 print. And then I did here on the actual command. And this one, you can see -n is defined, this and that, but print. So all of that options are there The nice thing about it, if you do set, what is that the name? Star.sh, set, sorry, set to dash n .sh, dash n option. So if I run it, this is my actual script input file. In this case, my input file has that one, but I'm not gonna see the rest of them later on. I'm only seeing the line because I'm doing a minus n with p option. So in this case, notice that cat was changed to dog and only shows this line, which is the third line. For line 1 and line 2 was not printed because I used the minus n. That suppressed the other command, the arguments, the other lines that did not match. So in this case, I'm doing more than one substitution. Cat to dog and quick to brown. It picked up both of them. The quick brown fox jumps over the cute small dog, and the cat changed to dog, and then quick changed to fast, as you can see. The rest of the command, the furious line, the ferocious line, that one was not matched. And then this one, I'm doing a set on the word da to that. And since it found of all 3 lines, it modified all 3 of them. Then the next one is matching all 3 from title, which is the first 3 lines, and it does that. And the next one with 1p only modifies the first one, not the second one. The 2 should go to the second one, as you can see here. This one and this, that, and then that. The first line was not modified, as you can see, which is good because 2 says the second occurrence. And then the GP, globally print, it will match everywhere. That was, the first line was matched, and as well as this other one. And then the file, again, is reported back to normal. Nothing was modified to the file. Okay. The next file is set 3.sh, more set 3.sh. Okay, this script uses the already prepared regular expression file. Okay, so in this example, we're using the -f option. Set -f, meaning that it reads a expression file or a script file. In this case, I prepared this express.set. The reason you want to give the extension .set so it does not get confused with a bash script saying that, oh, this bash script doesn't work. It's a set file that you pass in as an argument, and that's why I name it express.set. And the reason I call it express is because it's an expression. The ION is missing there, but doesn't matter. As an expression. So right here is the same file. This information is already there. In this case, I didn't need these ones because I'm already saying that the file are already there. Let me see. Actually, yeah, the file is still there. It gets created. So I'm not going to remove that line. The expression is the already existing file. Yeah, and then file and use the input file below to make, okay. So the comments over there is accurate. Let's see. So in this case, it creates that file and then it comes out here. It uses set -f option. -f means that the argument is a script file, -f a file. Now, normally on Unix, when you put a F options for some commands, it looks for a configuration files. In this case, is a set file as an input file, as an expression file. So this is that -n -f express .set. I may not need -n, doesn't matter. If you run it, it's okay. In either case, you could do it, suppress the output of the rest of them. And then the input file was read as, but did not update it. Okay, so this is telling you the contents of the files that I'm creating afterward. And I have to show you the express.set file, because right here, as I'm doing this command as -f express.set, inside this one, I'm just creating additional files. One is called outfile.set, one is called outfile-g.set. So let me show you the express.set file. So cat expression.set. Maybe I named it a couple of places there. Let me just modify the file called vixset3.sh. vixset3.sh. Okay, so express. I'm gonna just say expression dot set file. Okay, in this case, this is regular expression, and then expression dot set file, and expression dot set, the expression dot set. Okay, one place I had a typo, expression dot set. Okay, it was in the comment section, it wouldn't hurt anything. So now I go expression.set file, and that file basically is saying that substitute cat to dog and write the output to outfile.set. And the nice thing about it is when you're writing within the same expression, it appends to the file already existed. It doesn't override it, because if it doesn't exist, we'll just create it. But right here, I put everything up to a point to this one, and then the last one, I only put it to -g for globally to another file. So when I run the set3.sh, you can see it says this is my input file, and then this is my expression set file that I'm running, and this is my command that I'm running, set -f express.set in file. So this is the command that reads this expression set file, and then inside each of these lines, it goes through it, and then it looks at this data file. For example, on the first one, substituted cat to dog and write the output to outfile.set. Then it goes through the second one. Remember when I was telling you the set is goes through one pass? And once it goes through that one pass, and then it finds it after a while, it is already done with all the searching. It doesn't go a second read to the file. So it passes through the entire file once, and then it does all these string manipulation, search and pattern matching, and transferring it to another file or something, and it does that. So at this time, it does this, and then at the end, it writes it to another file for the global part of it. So at this time, the input file was read and only did not get updated. That's the file. And then the content of the new file, outfile.set. This outfile.set should contain all of those line above that was like this, because I'm doing all of that one to outfile. So outfile is a little bit longer, as you can see. It matched it, all those words. And when it finds it, for example, one of the word was hyenas was changed to deer, and then right there's, and deer was put there. And then small cat was changed to dog, a small dog, and then quick was changed to fast. The lines that did not match, it did not modify them, that's fine. But the last line, I'm changing the word da into uppercase da. So everywhere I'm saying globally and write the output to the dash G set. So everything else on that file is the same except the word change it here on those lines that matched it. And this is my comment section saying the content of the file is there. Everywhere else, the word da was changed, as you can see, to uppercase da. And then since these ones had that, and it was not there. And if it had da, I already modified it here to that. So that information was updated. You have to be very careful when you're writing multiple search and replace. Maybe that's not the desire of what you're looking for. So you have to go back and say, oh, what I'm doing here. Because sometimes when you tokenize something or parsing it, you may find out something that unintentionally or because of pattern that was matching and that condition, it didn't catch your eyes, but later on you found out the data was not looking for what you're looking for. You always do some validation. Data validation is another part of it. Tokenization and parsing is there. You might take a compiler class later on that ask you to parse certain information. When you do tokenization, this is part of the work. Whether you do awk or whether you do C language or C++ or Java, JavaScript, whatever language you use, you're going to do some string manipulation. Regular expression is found on all of those languages. And there's a lot of neat stuff with a lot of strength and functionality with regular expression. That's why I'm covering it a lot so you understand it on every programming language. Like for example, I was telling you about the cat command. Let me jump into the cat command. That's CUT, cut. If I just do the cut, and this example, let's say I do ls minus l star.sh. Sorry, ls minus l, no pipe. If I just do that, star.sh, I get the listing. But then what if I just want to know only the user ID, group ID, user ID, because in this case the group ID is the same. So I say user ID and size and the name of the file. So in this case I could say this, and then I could say awk print 1, 2, 3. $3 would be my user ID, comma, $5 would be my size, and then $9, 5, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, $9, $9 is the actual file name. $9. Where is the $9, number 9? Okay. Sorry, it's just the room is dark. Keyboard is sometimes I have a hard time reading it. Let me turn on the keyboard. Yeah, it's better now. Okay, so now I can see it better. Awk print $9. So if I just did that, I just need to close it. So let me just do this command again. There's some typo. Print $. Oh, this is not percentage, it's $. So right here, it just lists those files, right? And at the same time, if I wanted to print if, last time we learned we could do some header on the beginning. If you want, you could do that one. I mean, it's not a hard thing to do. Let me see what is going on here. Print ls minus l. Yeah, so it was okay. If I just do this one, maybe I could say begin and then use a brace here. I could say begin and then use a brace here and say printf statement, and I could say something like honor actually I could say the size here. I could say the size percentage, that's 6 character, let's say 6s, and then the next one is 5 characters. 5 characters, I'm going to say percentage 5 digit, and then the next one is let's say 10 percentage 10 s. So I do that one, and then I'm going to put comma, the $3. Actually, in this case, I'm going to say honor followed by size followed by script name. Okay, and then close that, and then since I did the begin there and then end there, just print it, but I want to just make it look nicer, so I need to do a /n here and print it. Let's see what it does. Okay, so it does print begin print ls minus l a star awk begin printf. So somewhere I need to do a bit awk minus this begin statement, printf statement, honor and $. See 1 second. My password awk my pass star. Okay, so we're doing a begin here, start it, and then all the way brace, and then don't close it. So in this case, you're not doing anything with the field separator or the space, number of rows, columns, percentage D, right there. Okay, so the second part, I need to do the same thing. Everything else is the same. And then set. I don't have to be in that directory, but I think it was there. So ls minus l, and then awk printf. Everything up to here is good. Just have to do another print here, and then put print. Okay, not print, and do printf, and then do percentage 6s followed by percentage 5d followed by percentage 10s followed by a new line and those values and followed by a comma here. So that prints it out, and then I have to close it. Syntax error, backslash not last character online. See what I just did. S minus L awk printf. S minus L begin is there printf, closing it, and then honor. Oh, I need to close that. Always a typo. And then size. I don't need a comma here. A colon here. Size and a script, and then printf 6D, 5D, a new line. And the new line was there, 3, and this everything else. So this is how you do that part. And basically it shows this information, honor, and then this one, it says digit. I need to print that one as a string also. And the first one, not 5 dash s. Now it's size, because you don't want to print a string as a digit. And then here is the value that is the $5 comes in as a value, so it is there. If I just clear my screen, unfortunately, the line that you run it just still says there as information. This part is part of it. So if I just cut and paste this one to a script, let's say vi t.sh, and then I put this line here and just say ben bash, and make sure that the cut and paste worked okay. Yes, it did. Now I run it, change mode 755 t.sh. Okay, so if I run t.sh, now it's much cleaner. I don't have the rest of the information showing us my actual command from the command line. And this time it also found out that t.sh itself. So the command t.sh, because it has list of all files. And if I just don't want to include that one, of course, I could grep out for it and say t.sh. Yeah, it is there. So I could just say grep minus v t.sh, and then pipe it. That would work. Clear screen t.sh. Now t.sh is not listed. So the grep minus v, as you know, it just takes out something other than the string that you're looking for, and it lists everything else aside from the string that you're looking for. Okay, so let's go to the example 4. So in this example 4, set 4.sh, and sorry, more set 4 and this one, we're looking at the same file, but this time we're doing a little bit different than other examples. So let me see what I'm doing here, because this example 4, the search for cat, replace it to dog and write it to a new file. So as we search for it, we're going to write it to a new file. And the way all it is instead of P for print or G for global or 1 for this, you use the W for write. And then a space by the file name, the new file. In this case, since I'm searching for cat and replace it to dog, I'm just creating another file called dog.sh. And then this other example, I'm searching for line in regular expression, but then the output, I'm writing it to line.set. And then line.set would have the information about that pattern that was matched. The input file is the same, and then the two files are showing here. So let me run it. Set 4. I'm going to do a clear screen first. Clear screen and then semicolon dot. So that would run both commands at the same time. The script creates an input file, which it did. And then at this time, I'm doing a set on it. And then it's a little bit verbose. Let me see what's going on here. It says no such file or directory. So there's a typo somewhere. Line 34. Line 34, the result to a new file, line 34. So set, substitute, dog to cat to dog, and file.text. There's a new line character here on the set. That's an example, that's fine. So on the example, the command that shows the error, I'm going to correct that one, set 4.sh. Let me just see what is this echo command. Why is it giving an error? So here I'm writing minus n. Oh, echo does not have minus n. Echo minus e. And then new line character. So the rest of them should be okay. Set there. So maybe quick thing I did set 4.sh. Okay, at this time it shows that input file, and it still says no such file or directory. There's one more typo. Set minus n dog in file.txt. Set line 34. Let me go to line 34. Set 4.sh 34. I should read it rather than just keep jumping to it. Let me see what's going on here. Example minus e and set this one and write it to set dot example input, and then on this example says search for this one. Okay, and right here there's a space. It shouldn't have a space when you search for something and then write it there. Line.
Is it the closing bracket after ION?
After ION, right here.
Yeah, is that supposed to be there?
Yeah. Oh yeah. Thank you. So here, this is, that's good, Jonathan. This is right here is bracket for that one, but this is extra because you're saying that search for the set, whether it's L or uppercase L or lowercase L, and then followed by line. So there was a typo here, and that's good catch, Jonathan. Thank you. So this one is gonna search for it with line. That would have not worked, but there was a space here also, and that the space saying that once you find it, then let's search it, write it to this file. Let's see if it works now. If it doesn't, we can maybe move the space back. Set 4.sh. No such file or directory, line 34. In file line 34, no such file or directory, set 4.sh. No such file or directory. Oh, okay. So it's still in the regular expression error. Set for. Okay, let's go back to line 34. And it says set minus E. Okay, this is an example, and somehow that is coming to the entire thing whenever we do this. So let me just do example minus E line. Somehow it is, I'm gonna just put this line up here first, then search for lion and do that. This is, if a line 35 has an error, it should still error out. Let's see. Yeah, line 35, save result to new file. No such file or directory. Why is this one pound? There's must be a extra line, uncomment. I think somebody showed up. Let me just see. Manage section. Okay. VI. VI set for data set. Okay, let's go again here. The search. Okay, and then this one is commented out. This one set minus n. Some string that is extra coming. Even if I do this one, I think it's coming from up here. Let me see, echo, yeah. Set minus n, substitute dog, and then substitute this to that. Read pause. Okay. At this time, it should not error out. It should come out, and then here I'm gonna just say break. Actually, not break, exit. So I don't want to just say this file doesn't exist. Set for $. Yeah, it still comes out with that line. So it is not line 35, because line 35 is commented out. And then later on it says here line 34 again. Set for $. Line 34. Okay, 34 is already commented out. There's when this happened on your script, look around to see if there's any closing bracket or closing parentheses or closing single quote that was missed somewhere. Those typos are really hard. Right here is input file. This one is the same, all correct. Read pause. It must be somewhere here. Echo example set minus n substitute doc, and then I'm gonna just close this one. Let's see if it finds it. Set $4. So this is a good thing that you can find out what is going on. Right here, let's just open one at a time. Notice I did these one. This one had nothing to do with it, but I'm gonna open this echo and this set command and this pause. And if the error shows up, the error is not on line 34 and 35. Yes, the line, even though it says line 34, it's from the above command, cut to dog. Let's see what is going on. So right here, cut to dog.
Is it the echo minus n? You said there's no minus n for echo.
Exactly, thank you. So sometimes like when you're passing one argument to the other one, that's the problem. My echo does not have minus n option. Echo is minus e for expression, and you just put whatever expression you want to do, write it, a string or a regular expression. That's what $F is going to translate. So this one now is going to work. Set $4.h, and the cut doc is working, no such file or directory. And line 35, can read $F. Okay, vi set $4.h. And then this file, nfile.txt is still there. So line 34, cut -e, this n file is not found. Set -n input file. Let me just type in like this, nfile.txt for now to see if it's still error out. And then the out file, and the out file, oh, the out files. Yeah, this one does, and there's right here, there's a problem. Out file, and then why we have out file here again? We're writing it already to doc. Yeah, this is the problem right here. wdoc.set, and right here, I don't need to do this. Because when we are writing it, we're writing to as this file, and this is the input file. So this one could stay as, and that $, in file. Okay. Sorry about that. And so $input file comes out as argument. I must have been writing it, and for some reason, the out file, which I named it, I decided to change it to doc.set because I was hard coding it to write to doc.set. I forgot to remove the out file here. There was an extra variable there. So let's see if that fixed that part or not. Set $4.h. Yeah, that file fixed it. Now we should have doc.set file, and doc.set file has the correct small dog instead of small cat. And then let's fix the next line, fix set for vi that file, and then go to the next one. We're going to do another echo. Again, it's an echo -e, not -n. Thanks, Jonathan. And then the next one we're doing here, so search set -n, search for this one, and then write it to line.set, and then write it here, line.set. And then again here, W should not be there, OF. And instead, we're already writing here. So this is extra that needs to go out. We're writing it to line.set and then input file. Yeah. Now clear the screen, set $4.h. And then the next command is doing the line, and now it's there. But I need to just show you that dog, and then the line.set, because those two files got modified and it's updated as so. So, and inside the set, we need to do set $4.h. At the end, we need to print out those two lines. Line.set. Right here, I did a exit. I'm not gonna do an exit, and that should run everything. Clear the screen, $4.h. There you go. And then the input file read is showing the input file, and now the new file line.set is there, and then the dog file is also there, a small dog, and then so that covers also example 4. See if anything else is there. Okay, so that covers all of the smaller examples. I need to show you some of the set commands from command line, a shorter version of the commands that you could do. So let's say I have the file clear screen nfile.txt. I'm going to just copy nfile.txt as temp.txt. So I'm going to work on temp.txt. If I just want to print the content of temp.txt, let me clear the screen, cut temp minus n temp.txt. If I want to print only those 3 lines, I could do something like this. I could use the cat command. I could also use the set command with the p option. The p option, whenever you do it by itself, it is just duplicating the lines. Notice that for every line, it's printed twice. Okay, so in order to suppress that one, you do use the minus n option. Now it's only 1 line at a time, which is nice. So if I just do the same thing, and I want to say only print line 1 and 2, that's addressing. At this time, I only printed line 1. If I want to say only print the end of the line, I could say $. It would print it, or I could say 3 because 3 is the last line. If I want to print line 2 only, I could just jump in line 2. So that address space, you could just do the same thing with print. But what if I want to do, say, 1 to end of the file? Notice the print, it's going to print all 3 of them. Let me clear the screen. It does print it. I'm going to just do, instead of print, I'm going to say, write it to a new file called temp1.txt. Now that output is not showing here, but temp1.txt just got created, and temp1.txt is basically the same copy of that one. We just made a copy of that one by writing that file. If I just want to override that temp1.txt with only line 1, I could do that. Now temp1.txt only has line 1. And if I just say search for word line on this file, it's going to say, sorry, I have to do the search. So search is this. You have to say search and then print. It will search if it finds it. Because escape, it did not find it. But if I put uppercase L, or I could do combination of saying that anything with A through Z, or A through Z in uppercase, I don't have to say know that exact word that it comes with L. Then it's gonna just find it. So in this case, if I just use the word the, HE here, it will find a lot of them. And then notice that it finds the word da here and then the word da here. If I just say change that one to something else, say change it to that in uppercase, it will just change those one to that. Sorry, I have to, this is search. This is search part. I'm doing, this case, I'm gonna do a search here. Search for this and then replace it with that. That would do it. So now it changed it, but I did not say print it, so it did not print anything. If I just say print, it will say the whole thing. I notice that it changed the first letter, but if I wanted to change these letters, then I'm going to do a G globally. Now, and then print it as well on the screen. So otherwise it just doesn't print it. So now everything was changed to that. And if I just want to delete a line for it, I could just say, let's say search, and then I say 1,3, print was printing it. But if I say 1,2, just line 1, let's say, print, it will only print line 1. But what if I just want to delete line 1 only? I could do that. And notice that since I did not print it, I have no idea what they did. So the only way you could do is that if you did this one, -d, send it to another file called one .d, let's say. And then one.delete as the line if you do this print command here. Let me just do that. One, no, actually 1D, and that would say line 1. That would say line 1 deleted. And yeah, because I did the suppress, that's a problem. So if I just don't do the suppress, -n, it will show the lines that are not deleted. So if I just say 1, 2, only show me the line, third line when I do 1, 2. Sorry, I'm saying 2 and I'm writing 2. Notice that third line is printed. So I could send this output of this one to say whatever name you call it, 1.d. Now 1.d will have that line. So rm1 line.d is going to do. So if I just want to say remove only the first line, and then send the rest of them to this file called tt. And then say more tt has the 2 lines. So the delete, if I just want to do delete by itself, and then this is wiping out everything. So now the tt is 0 byte. There's nothing in it. Without any argument, or I could do the same thing as d, or 1, $. That means from first line to the end of line, delete it. Now tt is still 0 byte. But if I just say do it up to line 2, meaning that keep the line 3, the last line, now line 3 has the last line. So that's deletion. I'm going to show you the insertion. Let's say on the file tt, on the file tt, I have this contents cut tt 1 line. I want to append something at the end of it. Then I'm going to say set the A for append, and then what I want to append. So I could say $A, meaning that at the end of the line, add this, and then I say, and this is the end of file marker. Let's say I could do that, and then close it, and then the name of the file is tt. So now it wrote the tt first, and then wrote the end of file there. If I change that to line 1, the address line 1, and then insert, so that would tell it that insert after line 1. And this will be inserted after in line 1, in line 1. So this will be in the first line, it will be inserted, and then this will just do that. If I change the insert to say, go ahead, do it on line 2, insert it, that will just say line 2. And then obviously I have to change the content of it to say this is inserted in line 2, and then the quick brown. But 2i, since there's no line 2 on it, it's only 1 line. I'm just doing it on the file on the screen. So all my statement that I was doing so far And this one, I had to write it to another file in order to just say, I'm going to update it because I'm going to do it on the screen. So let's say I'm going to send the output. I could do even T command, and rather than this, I could say send it to tt.text. Now let's see if while it is showing here, tt.text should have the same context. Now, if I want to just add it after the second line, which is this line, right? So I could say that command to I to tt.text, and then now this time because it's two line, it added that line on the second line. And if I want to send it to a file called, again, I could say ttt. Now I have it on the screen as well as that file, and that file is also having it. So append, deletion, all those options are always there. However, you want to insert, delete record. You also have options to map out certain strings to match out numbers. Inside the file, maybe you have a sequence of characters that you want to map it out to a new list of characters. You could do that one with set. What else command you have? Let me see. I'm gonna look at your book to see if there's any additional commands that they're showing that I should be covering. Character classes. Yeah, transforming characters. Transforming characters. So the way transforming works is like this. So clear the screen, I say echo, and this is 1 and 2 and 3, 3 and 4. Let's say 4. And then I'm gonna say, if I just write that one, basically it just writes the text that I'm writing on the screen. But now I'm gonna transform all those number 1, 2, 3 to something else, A, B, C, for example. Then I could say pipe set, and then the transform command is yes for Y. Just change 1, 2, 3, 4 to A, B, C, D. Let's see something I'm missing there. And for the, it has to come from a file. Did I do a typo somewhere? Typo set. That's set 1, 2, 3 Y is the one. Not sure why it's not working. Maybe this one doesn't support the transform command and terminated A, B, C, D. Maybe it's needs to not pipe it in this case. but it doesn't make sense for it to work on the other side. So let me say echo. This is 1 and 2 and 3 and 4 greater sign data dot text, and then I say set dash y 1 2 3 4 to a b c d. Yeah, okay. 1 2 3 4 a b c. That's it. Substitute it from data.text. It does it here, but the command line argument was not. So the echo command did not work. And
I think it might just be about ending with a forward slash, right? Because it says unterminated.
did I not? Oh, I did not put the forward slash. Yeah, always typo, man. Thank you. Yeah, the forward slash right here, I missed it. Yeah. So that's what it is. Thank you. So the transform is that you're doing a set of numbers to something else, and then the option is y, and it's changing it. Whether you do it from the pipe or from the file, you do the same syntax. Set. Who was that? Who was the last student?
That was me. It was Ted.
I'm sorry?
Ted?
Ted?
Yeah.
Thank you, Ted. Thank you so much. Yeah, I've been a little bit working too much on the screen. My eyes are getting tired and I just don't catch those. Okay, thank you so much. So we did cover enough for set and for awk, for geawk, and for cut and other ones. Let me see if there's something else we could do.